Hi students, welcome to WAPSI. So we can go to an interesting section called electronics. Okay. So the first question is, the electric current flowing through a given conductor varies with time as shown in the graph. So in this graph, we can actually see the variation of current in the y-axis and the variation of time in the x-axis. That means the change in y with respect to x. That means the change in current with respect to time is shown in this graph. The number of free electrons which flow through a given cross section. Okay, we want to calculate the number of free electrons in the conductor from 0 to 20 seconds. Okay, actually we want to calculate the number of free electrons which is passing through a given cross section in from 0 to 20 seconds. Okay, see what is meant by current. Current is equal to rate of change of charge. That means charge by time t. Q by t is called current. So actually, so the charge will give I into t. I is on the y-axis and t is on the x-axis. So area under the graph will give the total charge. Okay, so Q is the total charge and total charge Q is equal to I into T. That means the area under the graph. So from 0 to 20 second, this is the 20 second. Okay, this line gives the 20 second line and this is 0. So we can divide this into a rectangle, a square and a triangle. Okay, in the rectangle it will be, the one unit is 100. Okay, this is 100. So 100 milliampere into 100 milliampere into 20 seconds. Okay, that will give 2000 milliampere second. Okay, so we want to transfer the milliampere into ampere. 1000 milliampere is 1 ampere, so 100 milliampere is 0.1 ampere. So 0.1 into 20 is 2 charge, 2 coulomb. Okay, plus then we want to calculate the area under the square, that is 10 to 20 is 10 and 100 to 300 is 200. So that will be 0.2. 0.2 into 10 is 2 coulomb. Okay, then we want to calculate the area of the triangle. Area of the triangle is nothing but the half of the area of the square. So 1 coulomb. So total we get a 5 coulomb of charge. Okay, so then we want to calculate the number of electrons. Q is equal to NE. So E is equal to Q by N, which is equal to, Q is what? 5 coulomb. 5 divided by N actually we want to find. So N is equal to 5 by E. And 5 by, what is the charge of an electron? 1.6 into 10 raised to minus 19 coulomb. So 10 raised to 19 into 5 by 1.6. 5 by 1.6 actually we can, it is approximately 1.6 can be treated as 1.5. So it will be, I think we can transform this as 5 into 10 raised to 19 divided by 1.5. Okay, we can multiply the numerator and divide by 10. It will be 5 into 10 raised to 20 divided by 15, that is equal to 1 by 3 into 10 raised to 20, which is equal to 0.33333 into 10 raised to 20, which is 3.3 into 10 raised to 90. Okay, approximately. So that will be equal to option A. Option A is the correct answer, 3.125 into 10 raised to 19. Okay, then we can move to the next question. Let's move to the second question. The second question is, the IV graph for a conductor at two different temperature, 100 degrees Celsius and 400 degrees Celsius, is shown in the figure. See, inside the question they have given the conductor and the temperature is 100 degrees Celsius and 400 degrees Celsius. Okay, the temperature coefficient of the resistance of the conductor. So actually we need to find the temperature coefficient of the resistor. So what is alpha? Alpha is temperature coefficient, that is equal to R2 minus R1 by R1 into T minus R2 into T1, and R1 into T2 minus R2 into T1. Okay, so what is R? R is actually resistance. So we need to find the resistance of these states. Okay, the same conductor is using and the temperature is increasing. For a conductor, when temperature increases, the resistance will increase. But for a semiconductor, when temperature increases, the resistance get decreased and the conductance is getting increased. Okay, so you need to study the variation of resistance for semiconductor, for conductor when the temperature is increasing. Okay, that is very important. Okay, according to the syllabus. Okay, so alpha is equal to R2 minus R1 by R1 into T2 minus R2 into T1. Okay, so we need to find the resistance, and we have the velocity current graph, velocity on the x-axis and the current on the y-axis. So slope is what? What is the slope? Slope is nothing but dy by dx, change in y-axis by change in x-axis. In change in y-axis, the y-axis is actually I. So slope is equal to I by V. See, V is equal to IR, so slope is equal to 1 by R. Okay, so what is slope? Slope is nothing but tan theta. Okay, tan 30 is equal to R1. Sorry, 1 by R1, because it is I by V. For I by V, it is 1 by R. I 1 by R1, and for tan 45, it will be equal to 1 by R2. Okay, tan 45 is 1. So R2 is equal to 1. So R2 is equal to 1 and R1 is equal to root 3. Okay, because tan 30 is equal to, tan 30 means what? Sin 30 by cos 30, and sin 30 is 1 by 2 divided by what is cos 30? That is root 3 by 2, which is equal to 1 by root 3. So when we compare 1 by root 3 is equal to 1 by R1. So R1 is equal to root 3. Okay. Then alpha is equal to R2 minus R1. That means root 3 minus 1 divided by R1 into T2. T2 is what? Is the highest temperature, that is 400 degrees Celsius, minus R2 into R1. R2 into R1. R2 is what? R2 in here it is 1. So root 3 into R1 into, that means getting subtracted, that is 1 into 400, that is 400, minus root 3 into 100, which is equal to root 3 is approximately 1.71. Okay, that which gives 0.7 divided by 400 minus 1.71 into 100 means what? 171. 400 minus 171 is approximately 230. 0.7 divided by 230. We can assume that this is 700 into 10 raised to 3. Sorry, 10 raised to minus 3. 700 into 10 raised to minus 3 divided by 230. Okay, 700 divided by 230. We can do it. It is approximately 3. 3 into 230 is 690, remainder 10, 100 and 0, 3.0. So 3 into 10 raised to minus 3 is the approximated value, and the option A is 3 into 10 raised to minus 3. So option A is the correct answer. And what is the unit? In per degree Celsius. It is given inside the question. The unit is in per degree Celsius. Okay, so unit of alpha is per degree Celsius. So option A is the correct answer. Okay, next question. Next question is the third question. Okay, let's read the third question. An electric bulb of 60 watt 120 volt is to be connected to 220 volt. Okay, what resistance should be connected in series with the bulb so that the bulb glows properly? See, By the manufacturing company, they are saying that the watt power is 60 watt and the voltage is to be given to that bulb is 120 volt. But actually our source has what? 220 volt of potential. So excess potential is coming to the bulb. So we need to cut off that excess potential by giving a resistance in series, because in series only the potential get dropped. Okay. So we need to give a resistance. That resistance is called a shunt resistance, that to be given in series with the bulb for the glowing proper glowing of the bulb. Okay. So if this is the bulb, a resistance to be given. Okay. Here we have a source of 220 volt. Here we only want 120 volt. So how much of potential is to be dropped? 100 volt to be dropped by the resistance. Okay. Actually we want to find what? The resistance value of the resistance. So we know that V is equal to IR. So R is equal to V by I. V is given 100 volt. V is 100 volt. What is I? They don't give the value of current. So we need to find the value of current. That why they given the value of power. Power is 60 watt. Okay. Power P is equal to 60 watt. From this equation, we need to find what? The current. Okay. And we know that P is equal to VI. So from this equation, I is equal to P by V. Power is 60 and what is voltage? Voltage of the bulb. Don't take the voltage of the resistance. Okay. Actually we are calculating the current through the bulb. Okay. That the same amount of current is actually passing through the resistor. So we want to calculate the value of current by using the properties of bulb. Okay. So the power is 60 watt and divided by voltage is 120, which is 0.5 ampere. That means 500 milliampere or 0.5 ampere. So I is given and V is given. Voltage of the resistor is 100 volt. So the resistance is, voltage of the resistance is 100 divided by the current 0.5, which is equal to 200 ohm. So the answer is 200 ohm. Which option is correct? Option C is the correct answer, 200 ohm. Okay. Then we can move to our next question. Question number 4. Okay. In an experiment to determine the temperature coefficient. Okay, again the question is asked based on the alpha, the temperature coefficient of resistance of a conductor. A coil of wire X is immersed in a liquid. Okay. It is heated by an external agent. A meter which is set up used to determine the resistance of the coil X at different temperature. So different temperature is changing, but the conductor is not changing. Okay. The balancing point measured at temperature T1 is 0 degree Celsius. So initially the liquid is at 0 degree Celsius and T2 is 100 degree Celsius. So the change in temperature is nothing but 100. Are 50 centimeter and 60 centimeter. So we need to know. Already we need to know what is the relation between the resistance and given temperature. So here the resistance is changing by changing the length. So equation of the potentiometer is to be known. Okay. And if the standard resistance taken out is S is equal to 4 ohm. S is equal to 4 ohm is the connected resistance which is across the point here. This point. S is equal to 4 ohm. That 4 ohm is already, it is known. Okay. But the resistance of this wire which is immersed in the liquid is unknown. Okay. So we want to calculate the alpha. In order to calculate alpha, we need to calculate the resistance. In order to calculate the resistance, we need know the equation which is working inside a potentiometer. Okay. So by checking the idea inside the potentiometer, the resistance R is given as R into 100 minus L, which is equal to S into L. This is the equation which connect, or which is the basis of working of a potentiometer. That means the resistance into balancing length 100 minus L, which is gives S into L. Okay. So by using this equation, we can find each resistance R is equal to SL by 100 minus L. What is S in here? Already S is 4. So R1 equal to 4 into L1 by 100 minus L1, which is equal to, first balancing point is 50. 4 into 50 divided by 100 minus 50, which is R1 equal to 50 by 50 is 1. So R1 is equal to 4 ohm. Okay. R1 is, and the first case R1 is 4 ohm, and R2 is equal to 4 into L2. L2 is 60 divided by 100 minus L2 is 40. Okay. So 4 and 4 is cut, 0 and 0 is getting cancelled. So R2 is equal to 6 ohm. So R1 is 4 ohm and R2 is 6 ohm. Okay, we get the resistance and we get the temperature. So alpha is equal to R2 minus R1, 6 ohm minus 4 ohm, and 4 into the high temperature. High temperature is 100 minus 0, which is equal to 2 by 400, which is equal to 1 by 200, which is equal to 1 by 100 is 0.01. So 1 by 200 is 0.005. So alpha is equal to 0.005 per degree Celsius. Okay, per degree Celsius. So which option is correct? Option C is the correct answer. 0.005 per degree Celsius. Okay, unit is in per degree Celsius. Okay, so we can move to the next question. Which of the following combination should be selected for the better tuning of an LCR? LCR, inductor, capacitor and resistor are connected in series circuit used for communication. So better communication has to be done. So what means by better communication? In better communication, the quality factor will be high. So we need to know what is the equation for the quality factor. Since Q, quality factor Q is equal to 1 by R root L by C. Okay, Q is equal to, quality factor Q is equal to 1 by R root L by C. Okay, so that means quality factor is inversely proportional to R, quality factor is directly proportional to root L, and quality factor is inversely proportional to root C. That means L should be high and R should be low and C should be low. Which option is correct? By checking the resistance, it is fourth option is the R is getting low, and by checking the inductor to be high, that is also fourth option, and when we check the capacitor, that should be low, the capacitor, that is also fourth option. Okay, in the fourth option, the resistance is low and the capacitor is low, but the inductor is high, inductance is high. So which option we can take? The fourth option can be take. Okay, otherwise if in the fourth option the resistance is low but the inductance is high in the first option, we need to calculate all the values. Okay, we need to calculate this by numerical method. Okay, but they are making the calculation more simpler, so we only need to find their proportions. Okay, so we can move to the next question. Okay, in an LCR series circuit, the value of only capacitor C is varied. Okay, C is the changing quantity, capacitance is the changing quantity. Okay, the resulting variation of resonance frequency, that is F is the F naught is the frequency, resonance frequency as a function of C. So we need to derive a function with respect to C. That means F naught to be related with the C. So how we can relate F naught with the C? Which equation is connecting F naught and C? F naught means frequency. F naught is equal to 1 by 2 pi root L by C. Okay, that means F naught is inversely proportional to the root of C. F naught is inversely proportional to root of C, which is, that means when C increases, F naught should decrease. Which option is that? Option C is the correct, because in option D, when C increases, F naught is increasing, so it must wrong. And option B, when C increases, F naught is linearly increasing, that must also incorrect. And in option A, first increase then decrease, that is also incorrect. So option C is the correct answer. Come to the seventh question. A PN junction diode is connected to a battery of EMF 5.7 volt in series with a resistance 5 kilo ohm such that it is forward biased. If the barrier potential of the diode is 0.7 volt, neglecting the diode resistance, the current in the circuit is, we need to find the current. Okay. So actually, what is the effective potential in here? The barrier potential is given as 0.7. What is mean by barrier potential? That means actually that potential is acting as a barrier against the given potential. So here 5.7 is the given potential and 0.7 is acting as a barrier. So 0.7 should be cancelled by the given potential. Okay, that means from 5.7 a 0.7 should be cancelled to make the effective transfer of the electrons. Okay, with a resistance, so voltage, effective voltage is 5.7 minus 0.7, which gives effective voltage is 5 volt, and a resistance of 5 kilo ohm is, resistance is equal to 5 kilo ohm. Okay, and we need to find the current in the resistance. So I is equal to V by R, and V is 5 and R is 5 kilo, so which is equal to 10 raised to minus 3 ampere. That is 1 milliampere is the current. Option B, 10 raised to minus 3 ampere means 1 milliampere, because 1000 milliampere is 1 ampere. So 1000 into 10 raised to minus 3 is 1 milliampere. Okay, we finished our section. Bye.